Welcome to the AOCS Analytical Division ePoster page competition. We're so excited about our first ever pitch competition and look forward to the student presentations, hearing feedback and questions from our judges and audience. We wish the students well and thanks to our volunteer judges and the audience for attending, listening, and supporting this competition. Here's what will happen today. Each student will present for up to 5 minutes, which may include a visual aid, like a PowerPoint, but not the ePoster, since this would be very challenging to reach on a small screen. Audience who are registered for the meeting, watch the chat area for links to the ePoster found on the AOCS annual meeting website. After each student presents, a 5-minute question and feedback session will occur. Post any questions or comments or congratulatory notes in the chat area. We will try to address as many questions as possible from the judges and the audience during the 5-minute limit. This repeats for every presentation. When all students have presented, we will open an audience poll so that you can vote for your favorite pitch. Please take the time to vote for your favorite pitch. It's time to begin. In the Analytical Division pitch competition, we have 3 pitches from 2 contestants. Our first presenter is Kaavya Rathnakumar from South Dakota State University, and she's currently a PhD student of the Dairy and Food Science Department. She will present on extraction of dairy phospholipids using switchable solvents.
Good morning, and thank you everyone for coming to my presentation. I'm really glad to be part of this AOCS ePoster pitch competition, and I'm really excited to present my work on extracting the valuable phospholipids, which goes as a waste in the dairy manufacturing stream. Phospholipids are naturally present in the milk fat, and during processing, they go into the byproduct. For instance, buttermilk from butter, beta serum from anhydrous milk fat, procream from cheese whey. All these contain an enormous amount of phospholipids. Why these phospholipids are of great importance, especially the milk phospholipids, are considered unique because of the nutritional and health benefits. Consuming these phospholipids helped in reducing cardiovascular disease, cholesterol absorption. In recent times, it is used in the infant formula for the growth and brain development of the infants, and is also used in various processing aids as natural emulsifiers. Since this pandemic, the consumer trends on eating more healthy and nutritious food has come along the way these days, and these byproducts serves this purpose naturally. However, the challenge lies in isolating these phospholipids. Since it is a very wet dilute material, it goes through a multi-step complex procedure since it has to be concentrated, centrifuged, fractionated, which involves a lot of time consuming and also use a lot of chlorinated and flammable solvents, which are injurious to health and is economically unviable. And they use a distillation process, which is also causes various environmental hazards. In order to mitigate these challenges, we came up with a smart alternative is the use of switchable solvents, which is based on reversible reaction of amines. Thus, the change in miscibility, it's from water immiscible. It can switch on and off from water immiscible form to water miscible form by simply bubbling the carbon dioxide. When you remove the carbon dioxide, it goes back to its original form. And the magic lies here. You can reuse the solvent for several extraction processes. From this technique, we were able to obtain 99% of phospholipids from the bottom compared to the traditional methods such as the Falch and the Merjonia method. And it was interesting to note that it was remarkably high yield, like fourfold higher compared to the any other traditional methods as well as techniques which are in existence. In order, however, the extraction efficiency depended on the type of the byproduct utilized in the switchable solvent extraction. So, in case of the ultrasound, in case of the beta serum, in order to improve the extraction efficiency of the beta serum, an ultrasound pretreatment was employed prior to the switchable solvent extraction. And from this, we were able to obtain 70% of the phospholipids, which was 10 times higher compared to the beta serum, which was untreated. Further, this was applied into the ice creams, which was not depicted in my poster, which I did later on. And we were able to see 63% of phospholipids in the these phospholipids were mapped at every stage of the ice cream manufacturing process, and we were able to see interesting results in every stage of the processing, which I'll be working on this in future. And these phospholipids helped in converting a low value, this technique helped in converting a low value byproduct to a high value end product. In an economic point of view, this technique is highly beneficial as it is a sustainable and an eco-friendly way to extract the phospholipids from the byproduct source, and you can reuse the solvent, which makes it more sustainable. From this technique, we were able to and generate a higher extraction yield as well compared to any other techniques. And this project helps the dairy farmers in generating income by utilizing single drop of milk, and also it creates more business opportunities to industries by increasing the utilization of the dairy byproducts more effectively. In case of the ice cream, you obtain a converting a low value product to a high value end product, not only enriching it with ice cream with more nutrition, but also it's the phospholipids by itself serve as a natural emulsifier, and which I'll be working on in my future. Thank you.
Thank you, Kaavya. That was a great presentation. Judges, it's time for your feedback and questions. For those in our audience, please add your questions and comments in the chat. Judges, do you have any questions for Kaavya?
I guess I can go first.
Yes.
Great job, Kaavya. That was excellent.
Thank you.
Do you anticipate this approach could be used with other matrices?
So yeah, it can be used. This is a protein matrix. We are trying to disrupt this protein matrix and get the phospholipids. So similar way, it can be used for a carbohydrate matrix as well. It has been already studied, and so if it is so for the protein and carbohydrate matrix, we know it can be done. For other matrices, still studies has to be done to know like what type of switchable solvent will be used.
Okay, great.
I guess I'll jump in if you don't mind, Kaavya. That was a wonderful presentation. I'm very excited about your about your results. I have I guess 2 quick questions. You pointed out that you could reuse the solvent, which I think is a great result. How often do you think you can reuse the solvent, or is there a cap on how frequently you can reuse the solvent?
Okay, so theoretically, it is a reversible reaction which is based on a Le-Chatelier principle. So it can be used several times. Like it can switch back and forth several times by simply bubbling the carbon dioxide and removing the carbon dioxide. But however, it depends on the concentration of the lipids, or like the different material concentration, like some other minerals might have in influence, but we haven't studied that. But theoretically, it can be used like several times.
And does efficiency change as you reuse it?
Yeah, it might change. As I said, it might change depending on the concentration of the products.
Okay. And my other quick question is, how long is this extraction process altogether?
So it is around it depends, like from 3 hours. We have tried from 3 hours to 18 hours.
Okay. And is like the efficiency or the amount that you're able to extract, does it increase monotonically? Like with more time you extract more? Okay.
So we were when we used a temperature, we were able to obtain high at 60 degrees Celsius with time like 3 hours. But however, it depended on the type. Still more optimization has to be done, and to know like the exact time to get a very high yield. But with 3 hours we can get a higher yield.
Great.
Kaavya, this is Sneh, and great presentation, quite applied, and congratulations for nice piece of work. My question to you is, one thing which I observed in your results of the phospholipid extract from the buttermilk serum, I feel there is an enrichment of the phosphatidylinositol fraction in your phospholipid extraction and the extract. Do you know why it may be? Is it the nature of the way it is extracted? And then I'll ask my next question once you have opportunity to answer this.
Okay, so yes, so since this phospholipids are present in the outer and the inner membrane, we studied a mechanism study to know like how the switchable solvents interact with the inner membrane and the outer membrane of the phospholipids. This phosphatidylinositol are the enzymes which are present in the inner membrane, and the switchable solvents had an ability to go inside the membrane and extract these phospholipids, which is based on an ion pair formation. And so from that we were able to know that this linositol was higher concentration of phosphatidylinositol was there, like from our 4 different studies, like all were like the linositol was higher. But however, the presence of sphingomyelin and also other individual components like phosphatidyl, ethanolamine, choline were also present, and the distribution was studied using an HPLC, using charge aerosol acid detector, and yes, we were able to get that.
And my last question will be, if that's the case, that the enrichment phosphatidylinositol, and as you told at the onset, the phospholipids concentrated or isolated by this way may be useful as one of the health benefit ingredient. So what do you think will be implication if it is the phosphatidylinositol is enriched?
So as a whole, it has more nutritious benefits, but then we haven't studied the bioactivity, which can be done in future, and also like we are still working on the ice cream, like what are the individual phospholipids present, quantifying them at each stage of the ice cream manufacturing process, so that will give a more clearer idea on like what type, and also studying the bioactivity. But overall we know that have like anti-inflammatory properties, other immunological responses, and also it is used in the liposomal production of liposomes. So it's like overall we know that, but still we had to do the bioactivity to know how much it can be obtained from that. Thank you. I think you are mute.
Yeah, thanks a lot. Appreciate it.
Thank you.
Thank you all. Our time is up, and thank you, and well done. The next presenter is Steven Mascrez from the University of Liège, Belgium, and he's currently a PhD student of Jumblo Agrobiotech. He will present on a rapid and efficient method for Dialkyl ketones and Sterols termination in fat.
So hello everyone. So first I would like to thank the AOCS for the possibility to present my work today. So I'm going to talk about the method that we developed to analyze Dialkyl ketones and sterols in fat, and to introduce and explain why we analyze Dialkyl ketones. I have first to explain you the inter-esterification process. It's a reaction that is mainly used in industries like food or cosmetics field. And this reaction aims to redistribute the fatty acids in the triglycerides. And the aim is to modify the physicochemical properties of the oils or the fats. In this, it exists two main processes. So with enzymes, which is specific and fast, and with chemical reaction, so less specific. But in that case, it means that some byproducts are formed, and this is the Dialkyl ketones. And why we decided to develop on the Dialkyl ketone, it's a family compound that not so well analyzed. They just for at least method to analyze this and quantify. And consider that there's no regulation on Dialkyl ketones, we decided to merge with the sterol analysis, which is really widespread. And as a reference to compare our method, we compare with the International Olive Oil Council for the quantification of the sterols. And this method, especially for the Dialkyl ketones one, the use of solvent are huge and it's time consuming. So it's not possible as a routine analysis, and also it's not very green. So our goal was to decrease this, the time and the solvent. So as you can see in material method, we wanted to be more focused on two steps. So the saponification and the purification of the unsaponifiable fraction. So first, the saponification was realized by microwave to save solvent and time. And the heating up is more efficient than the classical boiling. Then a classical liquid-liquid extraction was made to extract the unsaponifiable fraction. And then, so this unsaponifiable fraction were loaded on a SPME. And we separate the fraction of Dialkyl ketones and the sterols. So what is important to notice is that the Dialkyl ketones are very apolar, so we get this fraction in just 10 ml. And then the sterols. So this method is quite flexible because we can analyze only Dialkyl ketones and or the sterols. And then after this, the collection of all these fractions were analyzed in GCFID for the quantification and by GCMS for the identification. And at the beginning, each sample was spiked with two internal standards, one dedicated for the Dialkyl ketones and the other one for the sterols. So first, before to talk about Dialkyl ketone, I would like to talk about the sterols part to have a comparison of our method with a reference. On the first bar plot, you can see the quantification of sterols, so with the IOC, so our reference, and with two conditions. So we keep the final condition of Mascrez, but we choose two solvents, ethanol and methanol. At the beginning, we wanted to work for sure with ethanol because it's greener than methanol. But during the meanwhile, of course, the COVID situation arrived and the ethanol price blew up. So it was a good occasion to see the impact of the use of solvent between ethanol and methanol on the final extract. And what we can see is generally the quantification is the same. We can see some little differences, but this it's especially for the really low compound in the olive oil, and especially this one are eluted close to the higher one, so the beta-cytosterol that can affect the signal of these. And then, so we wanted to also take advantage of the sterol measurement and to see if the interesterification had an impact on the sterol profile of different matrices. And you can see on the two bar plots on figure 4, so for the palm oil and the rapeseed oil, the comparison of the sterols, in one part, one side, non-esterified, and the other part with chemical interestification. And as you can see, we can conclude that there is no effect in that case of the interestification. And then, so for the Dialkyl ketones, it was a bit more tricky. Consider that they are not so well